Imagine opening your laptop without touching it. No keyboard, no mouse, no voice command, just a thought. It sounds like something from a science fiction movie, but it's already happening. Engineers and neuroscientists have spent decades trying to answer one incredible question. Can the human brain communicate directly with a computer? Today, the answer is becoming yes. The technology is called a brain-computer interface, or BCI. Its goal is surprisingly simple. Capture electrical signals produced by your brain. Translate those signals into digital commands, and allow a computer to respond. Every thought you have creates tiny electrical patterns as billions of neurons communicate with one another. Those signals are incredibly complex. For years, they were impossible to interpret in real time. Now, advances in artificial intelligence, machine learning, and neuroscience are changing that. Some systems use wearable headsets that sit on the scalp. Others rely on tiny implanted devices capable of detecting neural activity with extraordinary precision. Regardless of the approach, the mission is the same. Turn thoughts into actions. And honestly, watching it happen feels unreal. A person focuses on moving a cursor. The cursor moves. Someone thinks about selecting an object. The computer responds. No physical movement, no spoken words, just brain activity. One of the biggest goals behind this technology is helping people who have lost the ability to move or speak. For someone living with paralysis, even controlling a computer can completely change daily life. Sending messages, browsing the internet, operating assistive devices, communicating with loved ones. Things many people take for granted suddenly become possible again. But researchers believe the technology could eventually go much further. Imagine controlling robots remotely with your thoughts, operating complex machinery without touching a control panel, playing video games using only your mind, or interacting with future computers in ways that completely replace today's keyboards and mice. Of course, there are enormous engineering challenges. The brain contains roughly 86 billion neurons. No two brains are identical. Signals constantly change. Background electrical activity creates noise. Every system must learn to distinguish meaningful commands from countless other neural signals happening every second. That's where artificial intelligence becomes essential. Modern algorithms continuously learn how each individual user's brain communicates. The more the system is used, the better it becomes at recognizing specific intentions. It's less like reading thoughts and more like learning a new language, a language spoken entirely through electrical activity. And honestly, that's what makes this technology so fascinating. We're witnessing the beginning of an entirely new way for humans and machines to interact. Not through touch, not through speech, but directly through the organ that created computers in the first place. Will everyone someday control technology with their minds? Nobody knows. But one thing is becoming clear. The boundary between humans and computers is changing faster than anyone imagined, and the keyboard might not always be part of the future.